Hello. Today we're going to talk about composite functions, or sometimes called functions of composition. So our goal is to be able to understand what they are and also define the composition of functions and evaluate inputs using formulas and graphs, and also be able to understand how to find the domain of a composition of functions. First, let's explain what a composite functions or composition of functions are. Let's say we start with two different functions, f and g. What I call the composite function is written this way. This looks like a little circle. And we read it as f composed with g, or composed of g, means this. So anytime we see this symbol, what it means is my input for my function f is another function, this function g. So wherever I see an x in my function f, I plug in the function g. Okay. Now, it works just like a normal function, except we just do that, okay? And of course, as long as g of x is in the domain of f, so as long as you don't have any problems with the domain, like anything becoming undefined or imaginary, anything like that, okay? So as it says, the input for the function f is the function g. And also to be clear, this is not the same thing as multiplying the functions f and g together. This is something different. And a way we can visualize this is this graph here. So imagine we have two functions, g and f. We're doing a composition of f with g this way. So g is the input of f. So some number x comes in, g does something to it, gives us out a function, output g of x. Then that becomes our input for our function f, and out here comes this composition function, the result of that, f of g of x. Okay, a good real world example of a composite function is an assembly line. So if you ever worked on an assembly line, or if you've ever visited a car factory, something like that, a car assembly line, then you get the basic idea, or any kind of assembly line. Basically, some part comes, if you're working on an assembly line, some part comes to you, you add something to it and send it on to the next station. So the part that comes to you is essentially this output function g, and then you send that on to the next station. They do something to it, which is function f, and the output of that is this f composed with g. So let's take a look at a few examples of composite functions, kind of get the feel for how this works, and also look at some inputs. Then we'll discuss domain. Okay, so let's look at some examples. And let's say we have some example functions. So let's say we have these three functions we're going to use. F of x is going to be the square root of x plus 1. G of x is going to be 2x minus 3. And finally, I have function h of x, which is going to be 3 over x minus 4. Okay. So let's take a look at our first example then. So let's simply do this function written this way. F, make sure this is like a circle. So I'm going to write that a little bit better. F composed with g. Okay. Or since you may see it like that, or like written over here, f composed with g of x. Okay. Once again, what this means is my input for my function f will be my function g. Okay. So once again, what that says is my input for function f is going to be g, and g is 2x minus 3. Okay. So wherever I see an x here in f, I'm going to replace it with 2x minus 3. And what that's going to look like? It's going to look like this. So the square root of x plus 1, I'm replacing x with 2x minus 3 plus 1. Then, of course, simplify if you can. We can. And so this is going to be the square root then of 2x minus 2. Okay. That is our composition function. So we created a new function with potentially new properties. Okay. It doesn't work like either original functions. All right. And that's our composition function. Now, let's take a look at another one. And also, this is not mathematical word is commutative. This is the order here is important. Okay, so if we do the same thing, let's do g composed with f. Of x. Okay, let's do the other order. Now, what's that going to look like? Well, in a similar way, it means my function g is going to be my function f. And what that means is my input, my function g, is going to be the square root of x plus 1. So in my function g, wherever I see an x, I'm going to replace that x with the square root of x plus 1. And so if I do that, this is going to be, remember, g was 2x minus 3. This going to be 2. Instead of x, I put square root of x plus 1. Doesn't matter if you use parentheses or not. The square root of x plus 1 minus 3. Okay. Then simplify that. So I can just multiply it. Don't have to have the parentheses anymore. So 2 times the square root of x plus 1 minus 3. And here, there's no really good way to simplify that any further. So I'm just going to leave it like that. So this is my function g of f, g composed with f of x. Okay. Now, let's do a third one. And I'll go ahead and start right here. So 3. How about I do h composed with g? Okay, so it can also be written like this: h composed with g of x. And once again, what that means, the input my function h is going to be my function g. So wherever I see an x in my function h, I'm going to replace it with g, which is 2x minus 3. So remember what our function h is. Like up here, it's 3 over x minus 4. And so if I do that, then it's going to be 3 over x minus 4. Replace the x with 2x minus 3. Also minus 4. There's minus 4, not plus 4. Yeah, minus 4. And then I just simplify this. And so it's going to be, well, let's do it down here. So only one thing to simplify. Combine your like terms in the denominator. We have 3 over 2x minus 7. I was going to say we have now a new function. It's got a new function with different properties. Actually, different domains, ranges, all other kinds of properties. This is h composed with g of x. Okay. Now, let's mention one thing about inputs. So if we have a function like this, let's talk about how we can do an input. Yeah, I actually have something I need to, well, I'll move this here in a moment. Let's do an input. And show a couple ways we can do that. So what if I have an input? Or actually, I should probably say find the inputs. So number 1, let's say that I use this function I just did, h composed with g of, let's see, what should I pick? I just something simple like about 5. Okay. Now, a couple ways I can do this, and I'll show you both. One way is, now that we have our composite function, is just simply to plug it in there. Okay. And so this is going to be 3 over 2 times x is 5, minus 7, is equal to 3 over 10 minus 7 is equal to 3 over 3, which is equal to 1. Okay, so for this composite function, if I plug in a 5, my input is 5, my output is 1. Now, that's one way we can do it, but another way okay, is find g of 5 first. Then we just plug that result into my function h of x. Okay, let's explain that. So we do it this way. So g of 5, remember g, the function g, is 2x minus 3. Let's do that first. So that's going to be 2 times x, which is 5, minus 3. Okay. So that's, of course, going to be 10 minus 3. And that's going to be 7. Okay. Now, if I think about once again what this means, h composed with g of 5. Now, the way I explain this is also we can write this as write it this way in more of an input form. So my input for my function g is 5. And that result, my input for my function h then is a result of is g of 5. So we just saw this is going to be h of 7. Okay. Now let's do that. So h of 7, or my function h, is 3 over x minus 4. So 3 over, replace x is 7 minus 4. And it's going to be 3 over 3, which is 1. Okay, so I'll just say wrap that up and say, so h composed with g of 5 is h composed of like that. So the input for h is g of 5, which we said is h of 7, which is 1. We get exactly the same thing. So you can do it either way. So you can either create, if you haven't already, you can create your composite function, and then do your endpoints, or sorry, inputs, or you can actually do essentially your inputs in order. So do the plug in the value in the first input, the function, do that, then take that number, plug it in the second function, and do that. Okay, now let's take a look at the next idea. And so let's actually see how we can do this with graphs. So sometimes we have to use, instead of giving a functions in terms of a formula, we have to have a function in terms of a graph. So let's take a look at that. And I probably won't do all of these, but I'll do a few of them, and then you can also do some of these on your own as practice. Okay, so here we're using a graph. Let's look at part A. So f composed with g of 1. Now here, this is going to be a lot like what we just did, because we can't create a composite function without knowing what the function equations or formulas are. So what this means, as we did this last example, is my input for my function f is going to be my function g, and the input for g is going to be at 1. Okay, let's take a look. So the blue curve is my function g, red curve is my function f. So let's find. So find on x, when x is 1, what's g? G is negative 1. Okay, let's say that again. So when x is 1, look at my blue curve, then the blue curve g goes through when x is 1, it's negative 1. Now, I just find this value, so f of 1, on the red curve when x is 1, y is 0. Okay, so that's that composite value function value. Okay, let's do part B. Now, g composed with f. Now this a negative 1. Also, as I mentioned, these are not the same, but inputs are not the same. But in general, this is not commutative, meaning if you switch g and f, you most likely get different results. But in this case, we're doing a different input altogether. Now, so this says my input, my function g, is my function f evaluated at negative 1. So do exactly the same thing. Find negative 1 on x, our x-axis. Now we're talking about function f. So what's the y value on my function f? That's up here at 2. So f of negative 1 is 2. So then we want to evaluate g at 2. Okay. So oops, hang on. I just realized I made a mistake. Let me take that back on the first one. So bear with me. Sorry about this. All right. I realize I said this wrong. So here, let's go back to this one. So the first part, right, g of 1 is negative 1. But now I do f of negative 1. So I find negative 1 on my x-axis and go to my function f, which is the red one, and that's actually at 2. So I apologize for that. So hopefully that's cleared that up. when you change this. Okay, so once again, so I found the input g of 1 is -1, then evaluate -1 from my function f, and that's 2. Now let's go back to this one. So f of -1 is also 2, as we just said. Then I evaluate g at 2, okay? So find 2 on the x-axis. In this case, go down the blue curve. My y value is going to be -2. And so that is the value of g composed with f composed with g composed with f of -1. The result is -2. Okay, let's take a look at one more of these. Now, one thing we haven't done is a composition with itself, and we can do that. You can compose a function with itself. It follows exactly the same rules. You plug the function into itself. And so let's do g composed with g of 0. Works exactly the same way. So my input for my function g is my function g evaluated at 0. Okay, let's do that. So when x is 0, function g, the blue line, y is 0. So found that, and once again, evaluated 0 when x is 0 on g, y is also 0. So that particular case, my input was 0, my output was 0, but it just happened to be because of the choice I made. Now in this case, of course, since it's the same function, the order doesn't matter here. Okay, let's skip and let's do one more example with 3. So you can actually do as many function compositions as you want, and that kind of mirrors the idea of an assembly line in a factory. You're doing a lot of function compositions because you have a lot of different steps. You're adding something different at each step. So let's do part E. So this one, I want to do f composed with g composed with f of 0. Okay. So first step, let's do this down here. So once again, what this means, and this gets I have a lot of parentheses here. So my input from my function f is my function g, but the input for this function g is my function f evaluated at 0. So once again, let's read that again. So kind of work outward towards the inward part. So my outward function is f, its input is my function g, but my function g, its input is my function f, and then the input for last f is 0. Okay, so once again, just kind of work from the inside out. So f of 0, let's do that first. So f of 0, when x is 0, f, go up the red curve, is 1. So this evaluation, f of g, f of 0 is 1. Okay, now this is just like the ones we just did. G of 1, let's evaluate that. When x is 1, what's g? G is -1 on the blue curve, and y is -1. Then one last evaluation to do. F of -1. So when x is -1, we go up the red curve, which is f, y is 2. Okay, so that f composed with g composed of f of 0 is just 2. All right. Now, one last thing I want to mention before you leave is on domain of composite functions. Now, there's sometimes people use specific rules for these, but I think it's easier to remember the rules we already have for functions, for defining the domain of a function. So to find the domain of a composite function, use the rules to find the domain of any regular function. Okay, and remember what that meant was you have to exclude any values that make the function imaginary or undefined. Okay, so remember, imaginary is when you have under an even root in general, but most of the time we'll look at square roots when you have a negative under a square root or an even root. So you have to make sure your x values, your inputs, don't include any values that would make that happen. And then undefined, where undefined means you divide by 0. So make sure your domain doesn't include any values that cause you to divide by 0. And also, I've done if you've seen my previous or another video I've done about this, about functions and finding the domain of functions. Once you have your composite function, just do that exactly the same way. Find the domain. Okay, so what we learned today is how to make what a composite function is, how to create a composite function, how to do the inputs, and also for giving graphs of functions, how to find composite functions in that way. Thank you. Have a good day.